This conference will now be recorded.
So, myself Manoj Singh. I'm working as a solution architect in one of the company in the Netherlands, and my domain is basically airline domain. From last 5 years, I'm working in airline domain and ERP domain. So, so this session that we are going to start today, that'll that'll give you a basic idea of Docker containerization. And in today's world, if we understand this, containerization is most important part of cloud computing, right? So this will, whatever the discussion will be doing today, that will help you to like go for further reference when you'll start understanding the containerization orchestration framework or platform like Kubernetes or OpenShift. There you'll use these kind of concepts which we'll be discussing today or next Saturday, right? So though this topic is very large, but will not be covering that much of in that much of a scale, but we'll be covering that you'll be able to understand how we can create containers, how we can stop, start, what how we can use variables, environment variables, and how can we can start any process within the container, how to expose ports of container, these type of things that you'll probably when you'll start working on any orchestration framework where you'll use these kind of concepts. Mostly when you work on the Kubernetes part, when you try to run any image within the Kubernetes environment, whether it is AKS or EKS. AKS is your Kubernetes services, and EKS where this Amazon provided Kubernetes services. You'll be able to correlate whatever you will be doing today when you write your YAML configuration for spinning up any container within those platforms. Like hello.
Sorry to interrupt you, Manoj. Your voice is very low, actually.
Okay,
I'm not sure whether it is with me only, but I can't hear you properly.
okay. Let me leave this earphone and then I'll try. Hello. Is this fine now? Still same?
Is a better. It's much better.
Little better.
Okay. So and and sorry. So whatever we'll be discussing today, that will be used whenever you'll be working on any containerization orchestration framework, right? Uh, like most important when you'll understand when you're writing your YAML file for the spinning up any container uh, in the AKS or EKS, you need to write this configuration file where you'll be using this kind of commands, whatever we'll be discussing today. You must have heard that volume mounting we have to do during the orchestration, and we, environment variable. Let's say that you are running any application on any Docker container, and this application needs to communicate with another Docker container. And first application is kind of a web application, and another container running any database container. So this first application needs to know the database credentials and path. So those kind of environment variables, how can we set in our application to run as an Docker container? So these kind of things will be able to explore in this session, right? And uh, during the discussion itself, whenever you see that whenever you think that you need to ask something, then please interrupt me in the middle itself. There is no nothing like after session itself you'll have to interrupt and ask question. I'll try to like answer as per my best knowledge during the discussion itself. Right? Is this fine?
Yes, sir, perfect.
Okay, so let's be little more interactive. So uh, anyone who does not have any noise in background, please unmute yourself and then we'll start discussion. Okay.
Sure.
So yeah, so so like uh, last if you remember, if you have experience more than 5 years, and if you remember last 5 years, when you go back to the 5 years back, you'll not be recall that any type of these concepts was existing, even existing, then we were not discussing this much. Now these worlds, now we are living in the world of world of application, where almost all application is running in container, right? So what was happening in the 5 years back, and what is the difference now? So let's understand this. And to understand this, we need to understand this virtualization, right? So I have created a PPT. It is not very good, but still I'll be able to explain what I understand. And then understanding the virtualization, we'll understand the limitation of virtualization. And then on the limitation of virtualization, we'll explore the how this containerization overcomes this limitation of virtualization, and how we are using this container in great efficiency. Okay, so is this fine till now?
Yes, fine.
Yes, fine.
Okay, so I think you'll be able to see my screen, right?
Correct. This is will be.
Yeah.
Okay, fine. So one of the building block that we see today in the cloud environment is a virtualization, right? To understand this virtualization, let's look at the server. When we do not have to use virtualization. Let's say that this is the high-end server, some high-end servers purchased by your company, right? In this high-end server, basically this high-end server, when we talk about any server in the cloud computing terminology, we say that compute host, right? And the compute host means virtual machine, right? So any compute host, which is a virtual machine or physical machine, which comprise hardware such as processor, RAM, hard drive, and there could be a persistent memory, hard disk, something, and network interface card, right? So whenever you purchase any hardware or any server from the market, you'll find that these hardware will be there in your physical machine, right? And after purchasing, what you'll do, you'll install operating system on this top of this host machine, right? So this could be any operating system like Windows or Linux, any operating system, right? And then once this operating system will be installed, you'll be able to install any application that you want to run in your operating system, right? So everything is looks fine here. Now consider the same scenario when your organization purchase this high-end server and deploying any application on this server, right? And this must be a very high-end server that can handle multiple applications at the same time, or we can say that 20 application at the same time, so that all the memory, all the resources of this high-end server can be consumed, correct? So what happens, So your organization purchased this high-end server, but running only 3 applications, let's say, right? So what is the limit? What is the problem here? What is the limitation here? Do we see any limitation or problem? Yes. Actually, what happens? Uh, if you look at this complete 1 year utilization of or monthly utilization of your server, you'll find that the application which is deployed on your server is consuming only 10% of the like CPU utilization, CPU, right? Memory utilization is also low. So that means, let's say that 10 or 20% or 15% utilization is happening from this machine. So 85% of the utilization um, is not happening, right? So like that means you purchased as per your, I mean, your company purchased as per your future estimation that in future your company will deploy more application on this server. But still, when it started, the utilization is not as per the resource which is bought, right? So, and the second problem is that, let's say that you want to upgrade your hardware, right? And you have already installed your operating system on the server, and now you want to upgrade your hardware. Now, what will you do? You'll have to shift your operating system and all running application into another server. How will you do? That will be a problem, right? Another problem is this operating system is tightly coupled with this hardware, right? So this operating system you cannot port into this another hardware. Let's say that any hardware malfunction happened uh, within your system, and you want to move your application from this server to another server. What will happen? You will not be able to move your application from here to there, because your hard this operating system is like kind of tightly coupled in here, right? So let's see what happens. So what happens in virtualization is that virtualization, actually what it did, that it countered those limitations, right? So how it countered those limitations? We have one this hypervisor software, right? This hypervisor software is installed on the server. Even today you'll find that there are few machines, you'll find that where your virtual machine cannot be run, right? Only because this hypervisor software is not installed on those server. So this once you install this hypervisor software in your hardware, what happens? It creates a layer of abstraction, right? And this layer of abstraction, what it does is that it, it has a capability to divide all the resource, underlying resource which is used within this hardware system, like RAM or network interface card or hard disk. This hypervisor can divide those resources into multiple groups, right? Let's say that I'll be dividing uh, this RAM into two, right? We have a 16 GB of RAM. I'll divide into two, 8 GB, and now I'll try to install two operating system on this server, right? So 8 GB will be allocated to one operating system, another 8 GB will be allocated to another operating system. This can be possible only with the help of hypervisor. Hypervisor creates this abstraction so that operating system will not be able to find out the this kind of virtual division of resources, right? Okay. So
Okay.
So this is what diagram says, that once we'll install hypervisor, it will create a layer of abstraction, and this layer of abstraction, what will create? It will create a different segment of these resources, small segment of these resources. Fine. So now everything was working fine till now. Okay. So with the hypervisor, we were able to run multiple operating system on the same machine. And let's say that you want to run a Windows operating system along with the Linux operating system. All you have to do is that you'll have to in bare metal system, just you need to install this hypervisor. On top of that, you'll be able to install this operating system, right? So then here what is happening is that this all operating system has its own libraries, right? Own libraries to handle, and its own kernel to handle, right? So what is happening here is that see now the problem of this problem, let's say that this server crashes or anything happened within your hardware system, then as you have already virtualized your software or operating system, you'll be able to move this complete operating system into another properly running system, right? So this portability part that we discussed earlier, that can be handled here, right? So now we know this advantage of virtualization, that we can handle this portability. Now we are using the almost utilizing full resources whatever we have here, right? But there is another disadvantage here, or limitation we can say, right? And this limitation is handled using containerization. And before that, let me tell you this: whatever the hypervisor software that we are seeing, that if you'll read about the hypervisor, you'll find that there are two type of hypervisor software. First is type 1 hypervisor, and second type 2 hypervisor. Type 1 hypervisor, what happens? A type 1 hypervisor, this type 1 hypervisor is the one which will be installed on the bare metal, and then top of this hypervisor, you'll be able to create your virtual machine, and then on that virtual machine you'll be able to install your operating system. While in type 2 hypervisor, what happens? You have a hardware. On the top of that, you'll be installing an operating system, and this on the top of this operating system, you'll have to install this hypervisor software, right? So like in our operating system, in Microsoft Windows operating system, you'll find that there is an hypervisor already installed, that is called Hyper-V, right? And this all again enables this virtualization of our system. Okay, so any questions till now?
Hello.
Yep. Hello.
Manoj, so as far as the presentation is, so what I can conclude is that virtualization is that all the your RAM and your CPU utilization, what you can say is that, okay, it is not been shared in between with respect to the OS, right?
Right, it has not been shared, right? So what happens whenever you create any, I mean, whenever you install any virtualization application like Oracle VirtualBox, right? So and on Oracle VirtualBox, if you create any virtual machine, let's say that you are creating an Ubuntu machine in that virtual box, it'll give you an option to like allocate the memory, hard disk. These things you'll have to like select that how much memory and how much hard disk you'll be allocating to that particular operating system.
Correct. So it will be a burden if it is not been shareable, right? Means if it is virtualization, the utilization and the RAM, it is being fixed. It cannot be shared.
No, it's not burden, but it will be like let's say that you have a 16 GB of memory, right? And you
Mhm.
want to install like four operating system on your virtual box, right?
Okay.
So what you'll do that you'll divide this 4 GB of memory to each virtual machines,
Correct.
correct?
Correct. Correct.
And these
Yes.
these all virtual machines are isolated. The processes will not be shared across these operating systems, right? So there is a limitation here that even that virtual machine is not using that much of RAM. Let's say that that machine is not using 4 GB of memory. Still you'll have to allocate, and you cannot use that RAM again, right? That will be
Correct.
allocated dot operating system.
Yeah, it is being
Let
constant. Yeah.
Yes, yes. So these are the again limitation of this virtualization, right?
Okay. Okay.
And let's say that we have a mini virtual machine running on the physical server, and each of these would have an operating system such as Windows, Linux, or any other OS. And operating system uses these resources such as this RAM, CPU, storage, etc. It creates an overhead for every individual virtual machine on your physical server. Correct. So let's say that we need something like some kind of technique where even we need one we will be creating one virtual machine, but this machine will not consume that much of memory. It will consume only the memory which is required for to run a particular process, right? So we can always allocate a quota to that virtual machine, but what if will not have to allocate any quota to that machine, and that will be like that will automatically take care of that memory part, or like this storage part, right? Like let's say that any process within that machine is taking, it needs to take like 2 GB of RAM. It will take 2 GB of RAM, and anytime any process wants to like take 3 GB of RAM, it will automatically take that much of memory from the underlying operating system.
So it is, yeah, it is shareable, and it is means you are
Mem-
talking about Docker, right? Means these
yeah,
limitations are being covered by Docker, right? That is what I can understand.
yes, these limitations are countered by Docker. And now, when we say containerization, that means when we do any container, when you create any container, that quota will be determined by the process running within the container itself, right?
Okay. So that
So now,
advantage.
yes, that is the advantage. And now, what will happen? Let's say, we'll take another scenario, but let's say what will happen, you have 16 GB memory, 256 GB of hard disk. So you can run, let's say that you can run six virtual machine in your this laptop or system. But using containerization, with these only resources like 16 GB and 250 GB of storage, you will be able to spin 100 virtual machines if you want, right? So this is the power of containerization. So as long as the all these containers are not uh, defined any quota of these limitations, we can spin up n number of containers. Fine. Another example, let's say that you have an application, right, running in some let's say that I'm from Java background, so I'll say that, okay, I have created one application which uses JDK 1.8 version of runtime or SDK, right, to develop this application, right? And then there is another application which uses another version. Let's say that it this new application uses 11 version 11. So at the same time, if I want to install both the version on the same machine, it may conflict. The libraries may get conflict, right? So what we can do is that we can create a two container here, and within one container, JDK 1.8 will be running, and another container, JDK 11 will be running, and our both application will run. Fine. This is again one of the advantage.
So Manoj, so what I can understand is that we are just launching Docker and we are just giving two different environments so we can run our process, right?
Correct. So we'll be able to see how to do that. But before that, I wanted you to understand what is like container and how it is different from the virtualization, right? So, if you compare this container and virtualization, you'll find that the memory space, boot time, scalability, and portability are the main factor where both of these difference. Right. First thing is when we say memory space, virtual machine takes a larger memory space. Right. You'll have to allocate a particular memory space for the any virtual machine which will be which you'll be spinning up with the virtualization. While in container case, what happens that you just need to spin up a container, whatever the memory space is required, it will automatically take care. Okay. My sound is echoing to me.
Yes, the sound is going. Somebody, I don't know what happened.
Hello? Hello?
Yes, sir,
I
fine.
just
Actually,
yeah.
Shubham, please go on mute. Shubham, please go on mute
Okay.
because of you. Okay, so fine now.
Yeah. And boot up time. Let's say that you have one operating system installed in a virtual box, and when you'll start booting up your virtual machine, how much time it will take? It will almost take same time, whatever the time it will take to boot up your host machine operating system, right? And in container case, it will take I mean, within second or in millisecond, you'll be able to spin up any container, right? And scaling, as I said, that with the given resource limitation, you'll be able to spin up uh, like defined number of virtual machines. But in container case, you'll be able to spin up lot many containers, right? And portability again, so what happens, the portability happens in virtualization as well. So in virtualization case, what happens, you'll have to save that file. I don't know what to say that, but any virtual machine that you have running in your virtual box, you'll be able to save that configuration and port into another hardware system. And in the same case, container, what happens in, you just create a container. uh, you just create a container. I'll be using another term, image. I'll tell you the difference between container and image. But all you'll have to create an image. You'll have to push this image into any uh, repository, container repository, and anywhere you want to run this image as a container, you'll have to download it and run. Right. So this is the what we will I wanted to show the difference and the advantage of uh, container. See here what happens. This is the like this diagram shows the difference between virtual machine and container. If you'll see, then what is happening, this is your hardware. You'll be installing a host machine, host operating system on your hardware, and then on the top of that host operating system you'll have to install hypervisor. And on that hypervisor, what happens, you'll have to install operating system, and each operating system has its own library to run this operating system and applications. Whereas in Docker container case, what happens, you have a machine, you'll be installing a host operating system. On this host operating system, we'll be installing a Docker engine. Docker engine will be using the kernel of the host operating system, or the kernel of the Linux operating system. I'll tell you why I'm saying the Linux operating system. And it'll this Docker engine will create an abstraction of whatever the resources is available within the host operating system or the hardware level, and uh, same kernel will be used uh, for the application. And every container will have its own libraries, and on the top of those libraries your application will be running. Whereas here, every every container or every virtual machine will have its own operating system, right? Here also these operating system will be running in the isolated form. Here also, whatever the container you will be running, those container will be running in the isolated form. Fine. Okay, so
Manoj, one question.
yeah.
If you're using that hypervisor or Docker, will that not decrease the performance of the operating system, base
No, no.
operating
So
system that we are using?
no, no. So this is what, like whenever you think of the any virtual machine on the top of any operating system or container on top of any operating system, that means that operating system or that hardware is meant for that only, right? So like you'll not it will not be like that you'll be installing any application or any high-end server, high-end software in your operating system, and then again you'll be installing any virtual box, and then top of that you'll be installing any virtual machine, right? So host machine will only be dedicated for this running of this virtual machine or containers.
So you mean to say but these operating system are specifically designed for the Docker?
No, no, no. Operating system is the same. I'm only saying that if you are running any container on your any operating system, which means that operating system you are using for the container only. You'll not be installing any other thing on that operating system, right? And in case you're also installing anything on that operating system and running parallelly any container also, then container will not consume that much of memory. But yes, whatever the process will be running within the container, that will be using that much of memory. But your other application which is installed directly on top of the operating system will run fine.
Can we install Docker engine on bare metal machine, or we need to install on top of OS only?
I think OS only. We need OS only, Karthik.
Okay, fine, thanks.
Okay. So yeah. So let's now talk about Docker installation. Okay. So
Manoj, will you be covering the details, the four benefits that you mentioned of the Dockers, right? The memory space utilization, the boot time efficiency that it has over the conventional virtualization, and ability of spinning off multiple VMs, right?
correct.
And the portability aspect also. So would you be covering those internals as well? That how
Yes.
does
Yes.
Docker
Yes.
manage
Yes.
it? Because
Yes,
It's
yes.
important to understand, how it is able to, optimize the boot time when the virtualization, which has a dedicated usage of the VM. If you look at the virtualization by architecture and the layout, virtualization has much more control compared to a Docker engine, yet the boot time is much more slower, although the Docker engine is going to share the infrastructure across multiple VMs, right? So yet it is
Okay.
able to optimize that.
Yes, yes. What we'll be covering that will show you the boot time, right? But when I'll show you the boot time, how quickly the container can spin, you'll not be able to identify. I mean, you'll not be able to compare with the like boot time of virtual machine, because
Hmm.
container spin up takes only a millisecond, while this virtual machine spin up takes maybe minute or so, right?
Correct.
And then memory space not will not be covering that, because memory space, when we say memory space, whenever you spin any container, that will automatically take care of the memory, right? Whatever the memory or resource that needs to be utilized by that container, that will take care of that container itself, right? I mean, Docker engine itself, right? So there are options that where you can specifically allocate a memory to any container, particular
Hmm.
memory. Let's say that you want to give any container 2 GB of memory from your operating system, from your hardware, right? So that you can do, right?
Okay.
So what was happening, like it's not like container or containerization concept exists from last 2 3 years only. It was there from the 1960, I think, right? But y- if you'll read the background of container, you'll find that there are lot many container engines. Uh, Docker is nothing but a tool, right? Just to create
Hmm.
this container, right? You'll be able to find out other containerization application as well. In discussion, you'll find that there is a one very famous container, Alexi container, right? It was used by IBM in 1960s in mainframe systems,
Hmm.
right? So but why this Docker became famous? Because if you are going to use Alexi containers, the API that are there is very difficult to implement. So it's a low level API, and we as a normal person will not be able to use those APIs very proficiently, and will not be able to make our container as Docker does, right? So what
Okay.
Docker does is that it creates a kind of wrapper on the Alexi containers, right? And it exposes some endpoints which will be used by us, right? So, I mean, it's kind of high level API. High level APIs will be exposed to us as an end user, which we are using to create containers or to manage containers, right? Okay, so there is one another logic here, why we should use container, is that when if you see any most of the YouTube video, you'll be able to see you'll hear one term: what you build, what you run, something like that, right? What happens that anytime, like you or me, whenever we are developing any application, will be working mostly on Windows machine, right? And if you in general term, if you'll see in market, most of the market percentage, if you'll find that whichever application will be developing, that will get deployed on the Linux server or Unix server, right? So what happens when you are developing any application on Windows machine, and now on production server you will have a different operating system running on that operating system may cause some issue, right? So the thing is that uh, when you have your container available, you can develop your application and deploy your application there itself, and you can check whether application is running as per the production environment or not. Once your application will be developed, you'll be giving it to the tester, and they'll test that application running that container itself, so that there will be no environmental difference, no infrastructural difference between whatever you have developed, whatever environment you use to develop, and whatever the tester is doing their testing. Okay, so are you getting me what I want to tell? Hello?
Yeah, Manoj, it's
Okay,
clear.
okay. So So let's start with the Docker installation. Like, as I said, the Docker is nothing but a tool, right? Just tool to communicate in operating system kernel. Whatever the functionality we have in the operating system, if we want to use those, we can use this Docker tool. Like I mean, whatever the libraries we have within the operating system. If you want to use those library to run any application or any virtual machine, then that this Docker tool can help you to achieve that. Okay, so this Docker, if if you read the Docker documentation, you'll be able to find that Docker is basically meant to run on Linux environment, right? So, but we have some we have some application from the Docker itself, which will create a Docker environment, Docker runtime environment in Windows and Mac operating system as well. So as I said, that Docker is meant to run in the Linux environment, which means Docker basically uses Linux kernel only, right? So whenever we are saying that we will be installing that Docker on our Windows machine, that means somehow we are using Linux machine on our Windows operating system. Understand this. If you do not understand, please ask again. So what happens? I'll tell you. I'll show you as well. What happens whenever? Let me show this. So you see this. So we have two type of Docker. First of all, we have two type of Docker editions. One is Enterprise Edition and one is Community Edition. Enterprise Edition obviously comes with a different more feature, and there is a license for that. And this is the Community Edition that will be available for us to work and learn. Right. So if you see Docker desktop for Mac, Docker desktop for Windows, and Docker for Linux, right? So if you see Docker desktop for Windows, Docker desktop is the tool which enables you to create an Docker environment within the Windows operating system. Again, this Docker desktop for Macs is again same thing. It's a nothing but the tool, right? So when you will install this tool, what happens? That if you'll try to install Docker desktop for Windows on your Windows operating system, it will give you one pop-up during the installation, which will say that there are two checkboxes it will show, right? It will show two checkboxes. One of the checkbox will say like, if you check this box, if you want to use WLS2 something. I think last time Srikanth had asked this question. Srikant? Any Srikant is here?
No, I think Puneet. It was Puneet,
Okay, it was Puneet.
I
Okay,
think.
okay. So what happens? So as I said that Docker is also like Docker runs on the Linux operating system, right? And we have our Windows operating system. So what happens that we need an operating system or virtual machine which is Linux on the top of Windows operating system. So when you'll install Docker, you'll see there is an option WLS2 or something. What it does is that Windows operating system gives you a Windows subsystem for Linux. PowerShell. There is a Linux. You can say kernel is available within the window also. You see, when I say WSL, which means Windows Subsystem for Linux, there is a Linux kernel available in the Windows operating system as well, which will be used during the installation, and your Docker engine will run Linux on this Linux machine, whatever the system Microsoft has provided. If you are not selecting that option, which means you want to use the hypervisor software which is installed on this Windows operating system. And that means what you'll have to do during the installation, actually before installation, you have to enable an hypervisor. You see Hyper-V. Okay, so you'll have to enable this hypervisor software, which is a type 2 software installed on the operating system. This will again create a kind of abstraction on this. Once you'll install Docker, you'll see that here in Hyper-V Manager, there will be one virtual machine, Linux virtual machine will be created, right? And this Docker will be installed on that Linux machine. In my case, what I have done, I am using this Windows subsystem for Linux to run my Docker. Right. So once you'll install this Docker, what will happen? An icon of this will be appear in your desktop. When you click on this icon in your taskbar somewhere here, you'll find this icon. Its update is available, that's why the full icon is not showing, but again this is a whale icon only, whale image only with the container on top of this whale, right? This will like say it's starting, right? So once this Docker engine will start, you just need to go to PowerShell and type Docker version. So let's examine this Docker version output. If you'll see, there is a two section here, right? One says client, another says server. Okay. So what is this? That as I said that Docker is a tool which has which has an interface, which interface is exposed to us, and this is the client, right? Which is exposed to us, and whatever the command will be sending to this client will send this command or communicate this command to the Docker engine or the server, and the server does all heavy lifting, right? So it's a server responsibility to create that container, to stop that container, to run that container, or whatever we are doing with the container or image, that will be done by this Docker engine only. And if you look at this particular section, OS or architecture, you'll see that what operating system it is running on. It's running on Linux operating system. right? Hello?
Yeah.
Okay. Any question till here?
So Docker
Manoj,
in Docker installed in Windows, but is running on OS is running in Linux.
Correct.
So do you install separate OS for to
No.
after installation of Docker?
No, 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 no. That is what I am telling. When you
Manoj,
yeah,
yes, Manoj, can you please show this architecture on Notepad? That will be helpful. Or to the some other.
okay, this I mean you need this screenshot in PPT.
No, no, no. The architecture means how the client is communicating with that and all.
Uh, Client is communicating to server, you
Yeah,
mean?
yeah, yeah, yeah. Yes. In Paint, you can tell us. That will be helpful.
Okay, okay, okay.
So these commands are good, but that will be helpful if we have it somewhere here. Yeah.
So whenever we install any Docker, what happens that, okay, I'll write as well. What happens is that there will be two options. There will be two options, right? During the installation itself, you'll be able to select, or the option will be asked you to select that you want this WSL uh, to uh, virtualization something. I do not remember exact term.
Yeah, WSL2 backend.
WSL2 backend, right? Okay.
Yes, that second is the Hyper-V backend or and
Yes.
Windows container.
Yes. And then Hyper-V backend. Yeah. So Uh, so what happens, like WSL is Windows Subsystem for Linux, which is provided by Microsoft itself during the operating system installation, right? If you select this option, you do not have to go for the Hyper-V, which a Hyper-V is again kind of hypervisor software, type 2 hypervisor software, which is installed on the top of your operating system to create this virtualization. So when you accept this option, there is a Windows subsystem which is running in your background, and Docker will be installed on that, on the top of that. I think WSL minus L minus V. WSL minus L. There is some command which will tell you that which what is installed on this WSL. Okay. And if you are selecting this option, which means you'll have to enable that Hyper-V option from this Windows feature, and then your system will ask you to restart your system computer, right? And once you'll restart, then you'll have to install this Docker for Windows. And this Docker for Windows, what will do during the installation, it will create, and that time you do not have to select this. And what it will do is that it will create an Linux operating system, and that Linux operating system or virtual machine you can see in this Hyper-V manager, right? And once this Docker installation is done, you'll be able to find that once you'll do this Docker version, you'll be able to find two segment of this Docker. One is client and another is server. Okay, this is client and this is server. Okay, so what happens when when we provide any instruction to the Docker? We provide instruction to the Docker client actually, right? I'm not very good in Paint. We provide this instruction.
But the architecture is going means we are just getting the information how it is going.
Okay, fine. So
Thank you, ma'am.
from our perspective, our end user perspective, whatever the command will be giving, that will be provided to the client, Docker client only, right? And Docker client will communicate further to the server that this instruction has been passed by the end user, and you'll have to, that means Docker engine will have to execute those instruction, right? Say Docker, we are saying that, okay, create a container, right? We'll have some special instruction to creating a container, and that instruction will be received by this client. And again, whatever I'm saying, that this client will be receiving this instruction, which means again this client is exposing some APIs, right? That APIs will be used by us. Whatever we are typing here, that any command whatever will be typing, that will be API that is exposed by this client tool, and this instruction will be passed to the Docker engine, and Docker engine will, and I mean, let's say that this any image, let's say that we are saying that we want to create a container of Ubuntu operating system. You know Ubuntu operating system? Hello?
Yes, yes.
Okay, fine. Otherwise it will be difficult. Okay, so what client is saying that, okay, create a Ubuntu operating system container for me. So the instruction will be sent to server. What happens within the server is that in Docker engine only, Docker maintains a kind of cache within it, right? And first Docker engine validates its cache, that the request which is came for the Ubuntu operating system, Ubuntu machine, that image exists in our system or not, and in Docker cache or not. If does not exist, it will go to the any repository. I'm saying any repository, which means this time when we are using Docker tool, that then it will be the default repository for Docker tool is Docker Hub. Docker repository or Docker registry is the place where all Docker images are kept. Okay, official, unofficial images are kept at that repository, right? It's similar to what we have like Bitbucket and Git repository. Similar to that, we have a Docker image repository, which is Docker Hub. We'll discuss about that later. But for now, what happens? Server first checks in its cache whether this image exists in the cache or not. If it does not exist, it again fires an request to the Docker Hub, and it searches in the Docker Hub only. In search, it searches the Docker Hub repository, that the requested image exists here or not. If the requested image exists, the response will come back to the server, and then the server communicates this response further back to the client, and then client will show whatever is there, whatever the command output will be there in your standard input output device, right? I'll tell you, you'll be able to understand why I'm saying standard output device at this moment. You'll be able to relate when I'll use something standard input device. Okay, so this is how communication happens, right? Any question till now? If you'll not
Is
ask
it
question or you will not
is it
say
possible? Is it possible to have multiple repositories? Like if it
yes.
is not found in the default Docker Hub, can it
Yes,
point
it
to
is
some say
possible to
other?
have multiple repository, but then in that case, you'll not be using this Docker tool, right? Docker tool has a default repository, Docker Hub only. When you work on the other container platforms such as OpenShift, you'll have an option to configure your repository. Let's say that you
Okay.
want to create your own repository, or say that in AWS or Azure also, right? You can create your repository, Docker repository or image repository, right? So that also you can use, right?
Is what you're saying multiple repositories possible only with OpenShift, not by Docker standalone?
No, no, no. So Docker I mean, the default repository is configured for Docker Hub only, right?
Oh, okay.
But but the Docker command, the Docker client can connect with any repository.
Okay.
Okay. So I mean,
Do you mean that the Docker client can talk to any server, any Docker server, and that Docker server can have its own repository, or a Docker client will talk to only one Docker server, and that Docker server will have multiple repositories? Which one is
a
true?
Docker server client will always talk to server, and server will connect with the multiple repository, whatever you will be
Oh, okay.
specifying, right?
So client will talk to only one server. Okay.
Yes. Okay. Okay. So till now we saw that we installed this Docker, okay, and uh, at the time of installation, it may be possible that you'll not be able to install first time. Then you'll have to restart your system, or it may say that your operating system has not updated version of Windows subsystem of Linux, right? So you'll have to upgrade that subsystem. So it will give you option during the installation itself. It will give you option to update uh, this subsystem, or it will give you the link which will redirect to the exe. You'll have to download that exe and install in your machine. And once you'll be installed, you'll have to restart your machine, and then you'll be able to run Docker. Okay. Okay, fine. Till now, I think it's all good. So I'll show you something here. If you right click, see here, you'll see. Uh, yeah, you see the switch to Windows container, right? Right now, we are using this operating system, which is Linux. If I'll select this option and then again do Docker version, it'll be using the Windows container, which means it'll be using a Windows kernel, right? So what is the difference between these two? So the difference between these two is whenever you create any container using this kernel, right? You always create a container supporting Linux Linux distribution supporting operating system. I mean, say that, okay. I mean, if you are running this server, this Docker server engine, and you want to create a container of IIS, which is a web server from provided by Microsoft, you will not be able to, because for running IIS, I think we need this Microsoft operating system that is required, right? So any container which is not using this Linux kernel, you'll not be able to spin up. uh, am I able to explain this clearly? Hello?
Yeah, the
Yes, sir.
problem
I think.
statement is understood. Your problem statement is understood. I'm just waiting for the solution.
Yeah.
Switching to the
Okay.
Windows container, right? And then probably I'll ask you the follow-up question around client talking to only a single server, right? So once you complete that, probably I'll ask a follow-up question.
Okay, so I'll not be clicking to switch to Windows container, but because it will take some time to restart my Docker, right? So whatever the practical will be doing on this architecture only, Linux machine only, right? Will be using Linux kernel only, right? Okay,
On the
so
Linux kernel, no Windows images can be installed.
no Windows image can be created, right? So
Okay.
this
So there are
why
multiple.
this
If we require IIS in the machine, it will not be supported. So we need to spin up Windows server,
right?
right? Windows
Yes,
image.
correct. So why this? We'll discuss this as well. There will be a topic where we'll be discussing a base image, right? Any container which gets created, that container has a base image. Base image may contain an operating system or an application which has a base image of any other operating system, right? Let's say that I'll be okay. Do you know Tomcat? Tomcat is also a web server, right? Let's say that I'm creating a container of Tomcat, and Tomcat uses a Java, right? So at the time of creating a container, what happens? It will if you okay, it will be difficult to explain right now. Okay, we'll discuss it later. Okay, otherwise it will get confusing, and then we'll get diverted from the actual topic. So let's start our first uh, container. Okay. Before that, I'll tell you. Sometime I'll be using the term image, and sometime I'll be using the term container. So, what is the difference between these two? Let's take an example. You are developing an application, right? And what you have to do is that you'll have to your manager or someone asks you to create a template, code checklist template, right? Code review checklist template. We usually create this kind of template, and during the during the review or peer review, we always check that whether all checklists are okay or not. Whatever the checklist we have created, those all points are taken care or not, right? So you have a release, and before that someone is reviewing your code, and he created this checklist and given a name something like code review underscore checklist hyphen version 1 template dot doc, something like, right? So and peer review done, all checklists are marked okay, and you did deployment perfectly fine. After some time, let's say that like after a month or so, again there was again a new deployment is needs to be done, right? And during the sprint retrofit of this previous release, we identified some points that needs to be taken care in the next release. So what you'll do, you'll create another version of that template, right? And add those points that has been identified during the sprint retrofit, right? And you'll rename this template with the newer version, like code review underscore template whatever underscore v2, correct? And and most probably you'll be storing this template into some of your code repository or git repository, wherever your document has been stored, correct? So and fine, now what happens? Another new person came into the project, right? Now that person now gets this responsibility of reviewing code. What he'll do, he'll just go to the repository and download that template, create a copy of that template, and do the code review and uh, like do the code review and fill all the checklists, right? So what we are doing here, we have a template, right? And what we are doing, every time we want to use this template, or we want to do a code review, we are creating a copy of this template, and we are filling all the fields of this checklist, whether this particular item line is okay or not okay. And then we provide this template to the concerned person, whoever will be reviewing this checklist. So there is two things. One is template, and one which is empty, and another is the filled template, which is kind of working copy. Correct. The same analogy applies here in case of Docker image and container. Image is a read-only copy of a what you say application. Okay, image is a read-only copy of that of any application, and the container is a running copy of that application. Fine? Are you getting me? Hello.
Yeah, it is clear, Manoj.
Yes,
Okay.
clear.
Okay, so now what we'll be doing, we'll be running our first uh, Docker command. Okay, the first Docker command, as always happens in any other language, the first command will be hello world. So we'll be also starting from the hello world only. Right. So Docker run hello world. Okay. So when I hit, what happens, will analyze these lines, whatever is as came as an output. So what happens when we fired this command docker run hello world, that we are giving this instruction to the Docker client. Docker client goes to the server, and server checks whether this hello world image exists. Image, now see here that I'll be using the term image, whether this hello world image exists in the cache, Docker cache or not. If it does not exist, it will go somewhere in the repository, Docker Hub repository, which is the default repository, and download it. So when it didn't found this hello world image within the Docker cache, it says unable to find image hello world latest. I'll tell you what is the latest, but for now just ignore. Okay, I'll tell you this is when you see anything after the colon, which means it's a tag. Tag is nothing but a version. Just like template, we saw that we can have a version of template v1 and v2. The same way, this is the tag or the version of the image, and we'll talk about this later when we'll see how to create a tagged image. Okay, so for now, just analyzing this line, unable to find image hello world latest locally. When it says locally, which means it is looking into the local Docker cache whether this image exists or not. If it does not exist, then it will go to some place, some repository, and it will pull that hello world image from there. So it says latest, that is the tag pulling from library slash hello world. I'll tell you what is the library. For now, just understand that this is the namespace, or this is a kind of namespace, or this is a kind of identifier for any organization or user. Okay, so it will go to the Docker Hub, and it will download this hello world image from there. And here it gives you one number, hexadecimal number, right? So, uh, and I'll tell you what this number is all about. And then it says pull complete. Okay. And then once this pull is complete, it will give you another number. You see, there is another number, SHA, we say this SHA number, okay. And then this hello world has something running in the background. For that, someone has created this hello world image, and that is to display this instruction. So hello world is displaying this instruction. Welcome one by one what all this instruction, and will execute all whatever written here, right? But for now, we'll concentrate on this. Okay, so what happens here? Till now here it is fine, right? We'll go to Docker Hub, which is the default repository. Explore and then search. Okay, so you see this hello world is an official image. This particular image is downloaded in my system now. Okay, this image is pulled from the Docker Hub repository. Whatever you are looking at this right now, this website, this is nothing but a website or the web page, which is kind of application, front-end application, which is communicating with the another backend server, Docker backend server, with the exposed API of that backend server, APIs, which gives you the list of whatever the image is available within that Docker server, right? This website is nothing but just a kind of interface to tell the end user like us that what all image are available within the Docker registry. Okay, so this is pulled. Okay, now let's understand this. What is this? So before understanding this, let's download one more Docker image. Okay, though I do not wanted to show this right now, but still to understand this, let's download one Docker run Tomcat. Okay. So again, this Tomcat is not available in my local cache. So it will go to first, it will find search in local cache, not available. Then it will go to the Docker Hub repository and it will download that official image of the Tomcat. And if you see this time, there are multiples kind of fragments, right, which is being downloaded. So for this fragment only, I am showing this Docker and Tomcat command to you. What happens? Just go back to the analogy that we discussed about the code review template. Okay. So what we said that we have an image, and in first release we created this template, code review template. Okay, we listed some like 10 items within this checklist, code review checklist. Okay, and then we did a release, and during the retrofit we found two more item. We added that two more item on that checklist and made the final version of that template as a v2, right? Which means there will be which means there will be uh, two changes, actually, two, not two, sorry, one change. So there will be two version of that file. Here what happens, here also this Tomcat is an image. Okay, when the Tomcat image was created, there was one kind of first version of code review template created, right? And then on the top of that image, or on the top of that template, when we did any change, it added a layer on that image, on the top of that image. and that layer is this. Okay, and that layer, I mean, what happens whenever you create an image, a Docker image, you'll be adding a layer on top of any image you do modifications. So here, these many layers are added on the top of the base version of Tomcat, right? So anytime when you create an image, the image which will get downloaded will be downloaded layer by layer, and this you can say the intermediary layer that will be created, right? And the end of the, when all the pull will be completed, uh, final version of this image will be created in your local environment, and that will have a different SHA versions, right? So what happens? This Tomcat is now available in your cache. And now what happens if you will be doing anything with this Tomcat container? You will be modifying this Tomcat container, that you'll be doing on the top of that image in the running container. And if you are creating the image from that running container on the or the modified container, there will be one more layer will be created on that, right? One second, sorry. Okay. uh, okay, so this, when we create any image, we create layer by layer. When we um, when we pull any image, the same way it comes to us layer by layer. And anytime all these layers will be available in our Docker cache. So anytime we'll be using the same Tomcat, and we'll be using any other layer of that, a newer version of this Tomcat, that will also exist in our cache, right? So whatever the version or whatever the container will be running, that will come from the cache itself. And any of the layer which is we do not want to use, that will not be included in our image. We'll see this in practical. When we'll create an image, we'll see this in practical, doing hands-on. Okay, so for now I have two image actually now: hello world image and Tomcat image. So there is another command. So you'll not be able to stop it. So I'll have to stop with another command, docker stop. So let me tell you another command. So now we have two image existing in my system, right? So how to see all the images which is existing in my system? There is command docker images. Now you'll see there are two images, Tomcat and hello world, right? So now we have to stop Tomcat for now, right? So there is a command docker stop. But what to stop? This is the image. If we'll say that Tomcat, it will give you error. There is no such container, right? Because container, this is not container, this is image, right? So to view the containers, we have another command, docker ps. It will give you the list of container which is running, which is not in stopped mode, which is running. So every time you create a new container, Docker engine allocates a container ID to that container that will be unique across your environment, right? So to stop any container, what you have to do, you have to pass this container ID, sorry, Docker stop and container ID. Actually, this container is a long container ID that we saw here like this. Okay, this is the full container ID, right? Here it is showing few characters of that ID. And when you want to stop this container ID, either you can type full uh, ID or you can use 2 or 3 character from that ID, as long as the other ID does not have same the same character starting with, right? So once you'll stop, this container is stopped, and this is not reflecting. Why? Okay, now. So now this also stopped, right? Okay. So now let's back Docker images and let me remove this. So to remove any image which is there in your system, you have to use Docker RMI, remove image, and then image ID 97F. Okay. So it says that there is some conflict, and you cannot use this container because you cannot use this image because there is some container which is being referenced by being referenced uh, having reference of this image actually, but we already removed that container. If you see Docker ps, you will not find any running container. So where is that? So that is in the Docker cache that we already discussed, right? So Docker cache has that container somewhere, and it is not in the state of running. Maybe it is in the state of exit, but it is still there, right? So the way to see the whether it is there is any container in the state of exited or not, you can do Docker ps minus a. You'll see, okay, this command will list all the kind of history, which will give you the list where all the container which is already stopped or the container which is already running. All the containers will be shown here, right? If you see, this is the container which is being referenced with this image ID. So as long as this exists in memory, you will not be able to delete it. So there are two ways to delete it. Either during the image removal itself, you'll have to force it, or first you have to remove this, and then you'll have to remove this. Okay. So for forcing of by force removal, all you have to do RMI minus F and then container ID. Right. Okay. Now the reference is deleted. So now we can remove this as well. How we can remove? Dr. RM this time. RMI is for removing an image. RM is for removing an container. So 5C9, and this time it will remove. Now C Docker PS minus A will not be able to find container in memory. Okay. Any question till now? Hello?
As of now, I think there's no question. So I think, Manoj, we can take a break of 10 minutes. Again, we can start from 9:45.
Yes.
Okay. So guys, let's take a break of 10 minutes. Again, we will connect after 10 minutes. It will be 9:45.
Okay.
For
Okay.
the time being, I'm going to pause the recording. Again, we will replay after 10 minutes.
Hello.
This conference will now be recorded.
Yeah, Manoj.
Let me ask people. Can you reply in, please? Can we start now?
What recording?
No, no, no. People are back or not?
Okay.
Yes, yes.
Kural. Okay.
Yes, I'm.
Raj, Ranjit. I think most of the people will be.
Uh, if you are back, then fine. Any question till now, then we'll continue. Uh, Otherwise, we'll wait for the questions. Man, please reply. Otherwise, it will not be good for me as well. That okay, it should be two-way communication, not one-way communication, right? So whatever the question you have, you can ask. I'll try my best to answer. If not, then I'll try to find those answers and then give back to you.
Manish, Kural, Naveen, Pallavi, Puneet, Raj, any question from anyone?
I'm good. I'm good. Don't understand much, but I'm good.
What happens? I'll tell you what happens. Shrikant or Raj, Kavita, Pallavi, what happens? So when we do any session, my experience, I'll be sharing my experience. When we do any session and that session gets recorded, we do not bother to be there attentive at that time. And we think that that session is being recorded, so we'll be able to refer that session again later uh, in our free time, something like that, right? So if you are doing like that, then it'll be, I mean, not good for me as well as you. So, okay. Shrikant, are you there? Hello.
Srikant Jain.
Okay, let's ask everyone one by one whether the people are here or
See,
not.
it's a Mano, it's a human behavior. Normally, if people will be online, still they will not reply. So I would suggest you to restart.
Okay. Okay. So just wanted to know whether it is fine or wish we are going too fast, too slow. It's fine, fine, whatever.
No,
Like,
it's okay. It's okay, not fast.
okay, fine then. Let's. So let me go back to the prompt, and now what I'll show is that let's say clear the screen and say Docker images, and you'll see that there is only one image exists in my machine. Hello world, right? So first time when we ran this Docker pull hello world, you found that there was first line which says that looking or something is looking for that hello world in the cache or something, right? So let's try to run this hello world again. What will happen here? Docker run hello world. So this time we do not see those instructions which were given last time, right? Three lines were here, right? One was a pull request from library slash hello world. One was like trying to look into the local, didn't found, and then there was another, there is a SHA ID, and then pull completed. That is not here this time. So what happens this time? The one we discussed that whenever we fire any command, Docker engine looks in the cache that whether this image exists in our system or not. And if it does not exist, then it will go back to the Docker Hub and retrieve that image, download that image, right? And this time when this image is existing in the cache and we run this Docker run hello world, it didn't show that 3 lines. It just showed this instruction. Fine. So let's understand this. Let's demystify this statement Docker run. What is happening? Okay. So when we executed this Docker run command, there are two things which happened behind the scene. First, it created a container. Second, it ran this container. It executed this container, right? I mean, it created an image and then it ran that image to spin up this container, which means two separate processes executed when we invoke this run command, right? Which is Docker create and Docker start, correct? So, which means Docker run is combination of two commands. It may be possible, right? A Docker run is combination of two commands. Let's see this practically. So what we'll do, let me delete this Docker, whatever the command we have, hello world, right? Or let it be there. Let's create this container once more. Docker create hello. Before that, I want to show what is there in the memory. Docker ps think Docker ps minus a. There are two container in the memory. Let me clear this two containers. Docker rm 0a and ae0. Okay. So if you want to remove multiple container, what you can do is that you pass this ID separate by space, as much as number of container ID you can pass. There is no limitation, and this Docker RM will remove all those container from the memory. Right now, do Docker ps minus a, you'll not be able to see anything in the memory. Right. So let's create Docker. Execute Docker create hello world. This time what happened when we executed this Docker create hello world command, it just gave me this SHA identifier, right, and then exited, right? And if you see, let's see if any container is running or not. Oh, the container is not running, right? Let's see if the container is there in the memory. Yes, container is there in the memory and the container is only created. The status, if you'll see, the status is created, right? So let's run this time container. This create another container using the run command. So Docker run hello world. Okay, this time it ran, and now if you'll see Docker ps minus ps first, Docker ps, there is no container at this moment in running state. Okay, so let's go to the memory, and you'll see what you'll see that the first container is still in created state, but the second container that we ran is in exited state. Okay. Okay. So the thing that I wanted to tell you is that the run command, what it does is that creates and then run. Okay, so uh, so let's start this again one more time. This time Docker start -a. Hello world. Hello world. Okay, what is this? Docker start -a. Okay, okay. Docker start. Okay. Docker start so, -a and this container ID. Sorry, this container ID. I'm sorry. Yeah. This will give you output. So -a is something uh, which makes this Docker to watch for the output from the container in your terminal. Right. So, so what happens like here that run command creates an image in your local machine. It creates a container. It executes a container. Everything is doing, one command. But what if you do not want to do not want to execute any image? I mean, you do not want to create any container. You just want to download any container. So for that, we have another command which can be used is docker pull. Docker pull. So docker pull, what it'll do, it'll just download from the repository or registry, and then it'll place in your cache, Docker cache. So this time I'll do docker pull, let's say Ubuntu. Okay. So Ubuntu was not there in my cache, so it is being downloaded from the Docker Hub repository, and it is downloaded now. And now we can see that Ubuntu image exists in my system. Right. Let's check if the container, any container running, no container running. Let's check in memory. Okay. No Ubuntu container is in memory as well. Okay. So, hello. Any question till now?
No.
I mean, I think everyone's sleeping now. Only Kunal. Okay.
No, I think people are not sleeping. You can continue, no problem.
Okay. Okay, fine. So let's run this Ubuntu now. Okay. Docker run Ubuntu. Someone was earlier asking that can we run this operating system and that what is the boot up time, right? So when I hit this command, what happened? The Ubuntu operating system started and then exited. How we can say that just go to Docker PS, there is no process running. Docker PS -a, you'll see there is a one container which was created and then a command executed bash and then it exited. So the command, this image we ran, container created and exited immediately. So why this happened? Actually, what happens, I'll tell you. Unlike virtual machine, containers are not for the like operate to host. Containers are not to host any operating system. Containers are only for the specific task or process, like any web server you want to host on that container, or any application that you want to run on that container. or even the database server if you want to run on any container. That we do in this containers. But if we are expecting that there will be multiple processes running within the container, that will not be possible. And for that, container is not meant for actually. Okay, so what happened when we hit this Docker run Ubuntu, the container started, container gets created by the Docker engine, container started, and there was no process was running. Just one command was executed within the container bash, but there was no like for that bash terminal there was no input, and so that's why it exited immediately, right? So the container was alive only for a few moments, right? If you create any web server container and web server stops, then the container will also stop. Fine. In our case, we created Ubuntu container, it ran, but as there were no process running within it, it stopped. The command we saw above is the one we just did. It indicates that whatever the container we are running, what would be the default command which will execute, right? This command, about this command, I'm saying about this command. Whatever the container we are running, what command is the default command to run that container, that will get executed once. And if that command is not for the continuous running process, the container will immediately come into the exited status. Okay, so what is the use of this kind of container if we do not uh, keep this in running mode? So okay, so what we'll do now is that let's try to run this again, same Ubuntu container, but this time we'll try to make this container wait for some time. So what we can do is that Docker run Ubuntu, and as we have this bash command which is the default command, what we can do to override this default command, we can pass any command here. Sleep 10. So sleep will take another argument like 10 second, and what it'll do is that it'll instruct this Ubuntu container to wait for 10 seconds before coming to the exit state. Let's see what will happen. Okay, so for 10 seconds this container will be in started mode, and then once this process will stop, the container will stop. Now let's open another window, and this time we'll see the running container. Docker run Ubuntu sleep, and again on this window, let's see Docker ps. You'll see that the container ID created is this of Ubuntu image, and the command which is being executed right now is sleep 10 second, and it was created 3 seconds ago, and up the status is like up for 2 seconds, and the name, this part, what happens that anytime you create any container within the Docker system, Docker gives you a random name, any name. If you will not be providing any name to the container, Docker automatically gives any random name to your container, right? So you saw that when if you want to override the default command of container, you'll be able to do that using this uh, command, right? Okay, so which means, but we still do not know that whether this Ubuntu server already, when the container was created, whether it really created within this Docker engine or not, right? To find out, let's execute some Unix command here. Ls. Let's see what will happen. Oh, so this gives you the list of files or directory from the container itself. I do not have these folders or directories in my local environment. So whatever the command will be providing here, that is being executed within the container itself, and the output is shown here, right? Hello.
So these are the
Yes.
default directories. So in case if you want to create another directory from your side, is it possible to create or not?
Yes, we can create. So for that, what we have to do, either we have to pass a command here itself, or we have to go inside this container and create a directory within that system itself, right?
Okay.
Let's see if we'll be able to create a directory here, Docker session. It is created, right? But we cannot see because the output was nothing, right? So let's see if we can. I think this will not work. Yeah. So we'll see how to go inside the container, and then we'll create the directory, and then we'll list those directory. Okay. So
Okay.
from here, what we can do is that we can only override whatever the default command we have for that container. We can only override that command from here. Okay. So
Will you show, Manoj, will you show the steps to go in the container and then
yes,
run these commands?
yes. Why not? Yes, that's why we have this session, right? Okay. So what is happening here? Like I said, that there is no process running within the Ubuntu system. That's why we exit, like this container exited, right? So for this, what we need to do is that, let's say that it exits immediately, right? So let's see that how we can make this container to wait for some time, not like sleep command, but we want something to take from the R keyboard, but a standard input device to accept something from this side, right? So for this, what we have to do is that we have to use one flag while running this container. So Docker run -i and Ubuntu. See, now this container will not stop, right? Because what we did is that we mapped or mounted our input device with this container with -i, right? If you go to this another window and see, this is still running, right? This is still running, and this will keep running until you do not stop it. But there is no use, right? You'll not be able to execute anything. Why? Because you mounted your input device with this container, but you do not have any terminal to execute your command. So what we can do is that we have to like mount our input device. Along with that, we have to attach the terminal, bash terminal also, right? So that we'll be able to provide any instruction within this container. So let's exit from here, Control C, and then this time Docker run -i and -t hyphen t, or within same hyphen you say it. So this is the way we create any container in interactive mode, right? So this what we are saying that okay, mount my input device as along with this attach the terminal also, right? So now if we run Ubuntu, now come here, the default command was bash, right? So bash executed and we attach this terminal. We sent the we given the instruction that to container that attach this terminal, right? So now you'll be able to see prompt, bash prompt, right? Shell prompt. Now execute this command, okay? ls minus ltr or mkdir docker session cd docker session. Okay, now you have Ubuntu operating system running in your Docker engine. Fine?
Yes.
Okay. Now you can install anything you want, right? I mean, whenever any Docker, any Ubuntu container you are trying to like official Docker image, you download it and running as a container, you'll not be able to find all those commands which are like external to the operating system. Like if you'll try ping google.com, you'll find that ping is not available, right? If you say curl, you'll say curl is not available, which means only the required library which is essential to run this container will be available, and anything else on top of that, if you need that, you'll have to do or you'll have to install yourself, right? So
Hello.
and it may be possible that like you or me,
Hello.
I created a container, Ubuntu container, and what I want is that I want a Ubuntu container and a Tomcat running within that container I need, right? So I created that kind of container and I created the image of that container which has this Tomcat installed within it, and I push that image into the Docker Hub so that it will be publicly available. So if you are downloading that type of image, you'll be able to find other things apart from plain Ubuntu libraries. I hope you understand what I mean to say.
Yes.
Okay.
So one question: this Docker is as a available on Azure as a platform service, or we can use a VM, create a VM, and then create this Docker image on that VM, and then use this.
Where Azure?
Yes, yes, in Azure.
Okay,
This will
in
available as a
Azure
service.
is like, no. In Azure, you'll have to create a VM, and then top of that VM, you'll have to install Docker. Okay.
Okay, directly we don't have any Docker running
No.
environment, right?
No. You'll get a Dockerized environment, but that is, I think, AKS, Azure Container Kubernetes
Kubernetes
Service.
service.
Kubernetes Services.
So
Yeah.
Kubernetes service is used to manage the Docker containers.
Yes. So any orchestration tool like Kubernetes or OpenShift, what it does is that, like if you have multiple Docker containers, right? Look, whenever Docker or container where it is used, basically, uh, why this containerization is like I mean, why we are talking about containerization? Only because this new architectural pattern, which is microservice type of pattern that we are following these days, that's why we are talking about these containers, right? So in microservice architecture, what happens? That whenever you create any application and deploy this application in cloud environment, you do uh, configure your application in as an whenever the traffic load is more on your application, you'll do some kind of configuration so that your application or VM will auto scale, right? And in Azure, I think it is skill set or something, and in AWS it is called auto scaling. So whenever more traffic will be coming in your application, you'll define some kind of policy which will give that any time your CPU utilization is 50% or 70% or cross 70%, then this your application will auto scale, right? So what happens behind the scene is that two container or two virtual machine gets created, right? So same thing happens in Kubernetes as well, right? So whenever the load increases in any application, number of Docker container running within the I mean in terms of Kubernetes, we say that pod is a unit running smallest running unit within the Kubernetes environment. So number of pod gets increased, right? So this, if number of pod gets increased, every time the new pod will have a different IP address assigned, right? Let's say that I am running one application, it has some specific IP address, and again that auto scaling happens, another two instances or one instances get created, it will have a different IP address, right? So, how this Kubernetes environment will be able to identify that how many processes are running, how many containers are running, which containers are not responding, which containers are responding, how much load is on a particular container. So that type of orchestration Kubernetes does, right? And when doing this type of orchestration, Kubernetes need to manage these things like if say that any Docker container which is not responding, then Kubernetes what it does is it will destroy or kill that container and recreate a new container. Fine. Okay.
Okay, yeah, fine.
Okay.
So when you have
So
when you have Docker itself contain holds multiple images of an OS, then why we use Kubernetes? We can create multiple images of
no, no.
OS and
So
we
that
can
is what,
scale.
like, let's say that you are running one application, right? Okay, and this application is e-commerce application, and at the time of Christmas or New Year, the load traffic is more than expected. Now, what you'll do? You'll create a new instance of that application, right? Okay,
Yes,
and then let's say that two new instances you have created, and then after 15th January the load becomes like normal 30% CPU utilization became. So what you'll do, you'll again go and destroy two instances of that application to, right? Or
yes,
if you will not be destroying these two instances, what will happen throughout the year, that three instances will be running and you'll not have that much of load, you'll be consuming the resources, you'll be paying for that resources, right? That is not kind of economical for organization. So that kind of orchestration where something like someone comes in the picture and it will take care of that type of auto scaling whenever, and you'll be able to configure these kind of auto scaling rule within the Kubernetes itself, which will say that let's say that number of traffic per day. If number of traffic is more than 5,000 at in 1 minute of interval, then auto scale my application from 1 to 3, right? You do not have to do anything manually here. Kubernetes will take care of this, right? This kind of things.
Same we can do in the Azure skill set, as Atul told that in
So
skill set also
behind
it
this,
will scale.
yes, yes. So behind the scenes, same thing happens in Kubernetes as well. Okay,
Okay, the different way of doing same thing, yeah, right?
right. Here, what you are doing, you are creating a virtual machine, right? And in the
In
Kubernetes,
skill set.
you'll be creating a multiple containers.
Yeah, in scale set we are doing multiple virtual machine, and then in virtual machine we need to go create the same kind of configuration and so much headache. In container there is no headache of creating the same configuration whatever we have in dev environment, and we can go uh, recreate those environment uh, on those containers,
Y-
right?
Yes, and there are other things as well with the orchestration tool, like you can your orchestration tool can do a service locator function as well. Like, let's say that you have two or multiple service running in one environment, right? So your Kubernetes environment can do what it can do. It will register all those services in this Kubernetes environment, and any third application or fourth application service which will be coming into your Kubernetes environment and it wants to communicate with the existing deployed service, then it does not have to go directly to that service. It will go via your Kubernetes kind of it's a metadata which maintains by Kubernetes, which will keep the track of all running container, right? And the service which wants to communicate to another service, it will just go to the Kubernetes metadata to identify that that particular service is where it is running, what is the IP address or what is the load balancer of that service. So you do not have to worry about anything like how one service will communicate with another service, how it will locate if multiple container of that particular service is running every time IP addresses are changing. So those things you do not have to worry. And there are some telemetry data also needs. Also Kubernetes also sends some, can send some telemetry data uh, to other tools as well. So there are lot many advantages of orchestration tool.
Okay.
uh, okay, so now, do we want to continue, or I mean, now all practical part is left, right? Now what we'll see is that we'll run web server, we'll access that web server Tomcat from our local machine, we'll deploy application, we'll run a website from we can run website in the Tomcat server from our local machine. We'll do volume mounting, like you just update any file in your host machine and that will get reflected on the container itself, right? And
So for this,
yeah,
which application you use? Java?
no, I'll use simple HTML application.
No, no Java
Or
application or not Node.js applications or Angular or any other. Just simple
if
website,
you,
yeah.
yeah, if you want, I can use Java Web Service as well.
No problem. Whatever you feel like. Just before for the next session, can you
Hmm.
please also document the steps, whatever you did do in the session? Please document all the steps. This is the use for. creating the containerization application, and then we are making the changes here and then uploading the file. This is the Docker file we create. This is the YAML. I think YAML file will be created, right?
No, we'll
In the
create a Docker file. Okay. We'll not create YAML file. We'll create a Docker file. Okay.
okay. Yeah. So means for the next session, just if you can if you have some time, then please prepare some uh, word file like these are the commands, or you can also
Okay.
send some URL where we can see, because we whatever you told us, that's the only we are grabbing. If we are going to research on the internet, there are a lot of things available, and we will
Yes.
confuse in the metaverse, right? So you just give whatever your thought of think you're thinking, so you can paste or create a one word document and then
Okay. Fine. Fine.
send it across. Yeah.
Yeah. Can you see my screen? We'll go through all these commands. I just did a Docker help. Right. It gives us this command. So we may not go to the management commands. We'll see this management command like volume, because we have to do volume mapping. Other than this, there will be no command we'll be looking, but we can go through all these commands, right? Most of these commands we'll see. Okay.
Okay.
Okay. So
Manoj, will you
yeah.
also cover, some of the design principles and the best practices for creating a Docker image? Because as a consumer, I think, there isn't too much of discipline, but when you're creating a component which needs to be used by uh, multiple people across the globe, suppose, you're planning to upload something on the marketplace or a Play Store, then in such cases, what are the design principles and best practices from Docker image perspective? Dependency is one of the aspects, right? But in
Yeah.
terms of, if you want something like singleton or reentrant kind of a process, those aspects, if you can cover, that will also help.
Okay. Fine. Okay. I'll try to cover some. Okay. Design principle for Docker template. Right. Though we'll be covering this Docker Compose file as well, right? Where you'll
Okay.
see how we can create multiple containers at the same time. So most probably you'll be able to derive what you are asking.
Okay.
Okay. Anything else? Any question here?
And also Docker Swarm is something which is also used to
Yeah.
manage.
Docker Swarm is again containerization orchestration tool. Wait,
It's
it
like
is
it's,
from
it's like
Docker.
Kubernetes,
Yes, it's like Kubernetes only, right? But Kubernetes has more market capture, right?
more popular.
And more popular, yes,
Okay.
right. Uh,
So
but
Kubernetes is also not a platform as a service. We need to have some VM and then create a Docker containerize and then create a Kubernetes for orchestration,
uh,
right?
Kubernetes is
Service.
service, yes, but platform as a service we cannot say.
So it means how installation will go. First, you need to create one
No,
VM.
no, 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 no. You have this service available in Azure, right? All you'll have to do is that use that service. You do not have to take care of any VM. You do not have to worry any VM, right? Okay, I'll do, I'll try to create a Kubernetes service, okay, in Azure, okay.
Okay. So inside Kubernetes service, then we create
We'll deploy an
multiple
application.
Docker containers.
Yes,
But you said the Docker container will deploy on the install on the virtual machines. So how
No, no,
Kubernetes will
no, no,
relocate?
no. So no, no. What happens that Kubernetes creates this container, right? And this is not virtual machine. This Kubernetes itself will create this container, right? And it will maintain within that environment itself. Virtual
Okay.
machine will not come into that picture.
Okay. Directly Kubernetes will does the thing
Yes,
in the backend.
yes.
So then it will be costly, right? Kubernetes services are costly service because they are handling multiple Docker images and all.
No, 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 no. I think it will not be costly. It will be, I think it will be cheaper than what if we are using a virtual machine for each application. It will be cheaper than that.
Each application means one company has multiple applications, then it will be best beneficial. If one company
Yes,
running for single application, then virtual machine is cheaper.
yes, obviously, yes. For one application, I think we should not use, if this is the only one application and we want to deploy in Kubernetes, then like that kind of configuration, Kubernetes is not simple, right? We need a lot of configuration. We have to mount this volume storage spaces as well. Let's take an example. Okay, we'll do this in practical. Let's take an example where we have a MySQL database. Fine. You created a container of MySQL database. You created a database within this MySQL, and you created a table within this database. Okay, you inserted some record within the table. Right now, what happens after running some time? This container destroyed. Right, destroyed means it got killed or something happened. It crashed. So whatever the data that you had created with that container will not be there. It will go along with that container itself, right? It's not persistent. Whatever the data we create within the container, it resides within the container itself, and whenever the container dies, the data also, uh, gets erased with that container. So to overcome this, what we do is that we do a volume mounting, actually space mounting, you can say storage mounting. Yes. So what we do is that we'll create a folder, or we create a volume within the Docker container itself, Docker engine itself, right, or host machine, so that whatever the data or whatever the table we have created in the MySQL database, that will go inside that volume, right? And whenever this Docker container crashed and got deleted, this volume exists. And if you will spin up a new container of MySQL and map that volume with the new MySQL container, you'll be able to see all those data which you had created earlier in the first container, right?
Okay.
That is called data volume mapping. We'll do in practical.
Okay.
It will be like the session is a kind of, Docker is a very, very, you can say, learning is very big here, right? Because whatever you'll be learning for the Docker, that will be used in all other container applications like Kubernetes or AKS, EKS, wherever you'll be using, you'll see that same kind of concept is used, right? Running container, stopping container, going to see, enter into the container and see the logs of the container, right? Debugging the container with the logs and all. Those concepts are basic in the Docker, And on the top of these basic concepts, you can enhance your knowledge while working on this orchestration tool, right?
Yes.
Okay.
Yeah, it is simpler than application development though.
Yes, it is simpler than application development.
It's a configuration. Everything is done by Microsoft. We just need to configure. But application,
Yes,
everything need to be done by us.
yes, yes.
So it's very difficult.
Okay. So
So guys,
can we, yeah,
yeah, we
can
are very
we,
much close to conclude. And in case anyone have any question, you guys unmute and ask your question. If you don't have any question, then we can conclude the session. And next session we will have next Saturday, same time, 8 to 10 p.m. IST.
Yeah, thank you so much.
okay,
Bye.
thank you. Thank you very
Okay,
much.
thank you. Okay, bye.
Bye.
Thank you, Manoj. Bye.
Talk to you soon.
You can, Naveen. Bye.